So hello, here's a video about long multiplication, sometimes referred to as double-digit multiplication. Whatever you want to call it, it's multiplying more than one digit in a number by another number with more than one digit. I'm going to show you two ways of doing this. In the blue, the vertical method, and green, the grid method. Two different ways of working out the answer to a multiplication sum with more than one digit numbers, more than single digit numbers. I favour one of these over the other quite strongly myself, but I'll show you both and you can make your own minds up and hopefully decide I'm right. Let's just start with what you should already be able to do, which is multiply a number by a single digit. 237 times 4. Here's how I do it. I would do 7 times 4 is 28. Put the 8 there, carry the 2 across into the next column. 3 4s are 12, plus the 2 we've got at the bottom makes 14. Put the 4 there, carry the 1 across to the next column. 2 times 4 is 8, plus the 1 underneath is 9, and we give us 948. Maybe think about working out whether that answer is credible, and say, let's call 237 250, and you should know that 4 lots of 250 make 1,000, so our answer should be a bit less than 1,000, and it is, which do that always when you're doing this sort of thing. Give yourself an estimated answer, because it gives you an idea whether your answer makes sense or not. Ours does here, because we're amazing. Let's develop that. Let's develop that now. Let's look at 437 times 23. Okay, I'm going to set that exactly the same way, but let's just think for a second about what this means. What it doesn't mean is 437. What it doesn't mean is 7 times 3 and 43 times 2. Nothing daft like that. What it means is 437 times 3, and let's underline that. 437 times, not 2 is it? It's 20. So if we can do 437 times 3 and 437 times 20 and add them together, that'll give us 23 lots of 437, won't it? 437 times 23. So let's do that. We're going to do it on two separate rows. The first row, let's go ahead and do 437 times 3, which basically, if we get rid of the 2, is just exactly the same as the question we just did, isn't it? So let's do that. 437 times 3. 7 3s are 21. Put the 1 there. I'm going to carry the 2 up here this time. We'll keep it out of the way for us. The next one, 3 times 3 is 9, plus the 2 above makes 11. Put 1 there, carry the 1 above. 4 times 3 is 12, plus the 1 above makes 13. 3 goes there. Nothing else to do, so we can put the 1 in the next column, in the thousands column. Good. Right, now then, don't forget we had that 2, didn't we? And that's not 2, it's 20. We're going to do 437 times 20. When you get to the tens bit, the thing to do is to pop yourself, I'll do this in black, pop yourself a 0 in the units column, because that will make your answer 10 times bigger, won't it? If we pop a 0 there in the tens column, we can now multiply 437 by 2, and it'll give us the correct answer, because it's our 7 2s. 7 2s are 14. If I put the 4 there and carry the 1 across there, effectively I've written the number 140, haven't I? Which is what 7 times 20 is. But I don't have to worry about the 20, I just call it 2, because by putting the 0 in the units column, it removes any worry about that. So 7 times 2 is 14, so I put the 4 in the tens column, 1 carries across to the next. 3 times 2 is 6, plus the 1 makes 7. 4 times 2 is 8, that goes there, and that gives us our final answer there. Right, now that I've got those two rows, add them together, it gives me my final answer. 1 plus 0 in the units, 1 plus 4 in the tens makes 5. 3 plus 7 is 10 in the hundreds, carry the 1 across, so let's do that. And 1 plus 8 is 9, plus the 1 underneath makes 10. 0 goes there, and 1 goes into the next column. 10,051. Does that make sense? Call it 400 times 20 would be 800. Call it 400 times 25, which is nearly what it is, would be 10,000, wouldn't it? So I said 800, I meant 8,000, didn't I? 400 times 25 would be 10,000. So yeah, we're there or thereabouts, so that looks good. We'll do the same question with the grid method. Here we go. What was it, 437 times 23? I'm just going to skip to a page I prepared earlier with some squares in it. I'll show you why in a minute. Because I, as you might have realised, I don't particularly care for this method, but I'm going to show it to you anyway. As I understand it correctly, if I understand it correctly, actually, a lot of people have quite a lot of success with this, so I should put aside my personal prejudices and show it to you. 423, got it wrong already, is 400 and 20 and 3, isn't it? There we go. And 20, you know what, I'm not doing very well here, am I? It's 437, sorry boys and girls. 437, 430 and 7, and we times that by 23. So, again, not a good idea. Let's move that across a little bit further. And put that there, you'll see why in a second. 20 and 3. There we have it. Good. Okay. I'm now going to multiply each of these grids together. 400 times 20 is going to go in this box here. 4 2s are 8, and 3 zeros. 1, 2, 3, 8,000. 400 in the next box times 3 is 1,200, isn't it? 1,200. On the next row down, 30 times 20 is 600. 30 times 3 in the next one along is 90. And down the bottom, 7 times 20 is 140. And 7 times 3 is 21. Let's add each row up now to get our total. So we have to add 8,000 and 1,200. That's 9,200. I can do that. This is why I did the squares. 600 plus 90 is 690. And 140 and 21 is 161. Add those three numbers together. 0, 0 and 1 is 1. 0, 9 and 6 is 15. Carry the 1. 2, 6 is 8, plus 1 is 9, plus another 1 is 10. Carry the 1 across. 9 and 1 at the bottom is 10. And we get 10,051. Which hopefully, yes, there we go, was the same as the answer we got earlier, 10,051. So that's the grid method, where you partition the numbers into tens and units, possibly even hundreds if you have hundreds. Multiply each part by each other part from the other number, and that gives you your final answer once you add them together. I don't particularly care for it. I think it's too fiddly, and I think there's too many things that can go wrong there. But there it is. Two different ways of long multiplying. If you're not sure you follow the method, rather than me doing several more examples, why don't you just rewind and play the examples again, just to give yourself another look. Thanks very much for listening. Good luck.